All right, we are recording. This is the Dev Book Club. We're going to be covering Chapter 3 from Refactoring by Martin Fowler tonight. This one was all about bad smells in code, which I found entertaining. I think it's for me personally, it's like a lot of these things are just, I recognize them now. Like I don't really memorize the names for them. But you know, I have my select few that I want to talk about that are my favorites out of the general catalog, but I'm interested to hear what everyone else took away, or like what your favorite was, or that sort of thing. So we'll kick it off with that. Like, who has a favorite smell out of this chapter, or favorite that you like, that you see all the time, or which one do you write the most? Come on.
That's a lot of pressure right out the gate there. Just
I mean, I can go first. Okay, I'll go first. How about that? Okay, so my favorite one, and probably the one that I've been most guilty of my entire career of writing stuff, is the, what do you call it? Speculative generality. So it's the idea that, you know, your code could be much more grand than it probably is, and so you end up writing a bunch of stuff that, you know, could be, or it may respond to this change later, and it is almost always or rarely ever true that you need to do all that. So it's the whole Yagni principle, and I love looking for that and then figuring out like how to apply the various refactorings, which I found the list that he provided, that, you know, when you have like inlining functions, that sort of stuff, like I feel like I do those, but I never really think about the fact that that's what I'm doing. Like and part of it comes from, or at least I think that speculative things. So it comes from tools that I've used in the past that deal with looking at like complexity of stuff, and like how do you, like Ruby has Rubocop, which is real bad about this. Like Rubocop gives you these lists of things that the community in general has decided. I mean, you can configure it, of course, but like the baseline, it gives you all these things, and so you end up appeasing the tool, and you do that by like genericizing things or extracting stuff, or like adding layers of indirection that maybe aren't really necessary, but they get you past the tool. So there was another tool, Code Climate, that was also kind of, I don't want to say enabled this behavior, but it did, because you're chasing a goal, you're chasing a score in like Code Climate, and then to do that, you hack around it by adding all this weird stuff into your code. And then that just becomes habit. Like you naturally know that I'm going to have to do this to get past the tool. So I know I would find myself writing in generality where it doesn't need to exist. So like that one's my favorite out of this entire collection. So there you go.
I think for me, it's funny. I've got the book pulled up right here with the chapters, and the names never really like stick with me, so I always have to go back and refer to it. But looking at this list again, actually, like comments are something that I think about all the time. And the best client I ever had, they always came back. Like they were a developer partner with us, and they always came back anytime there was like a comment in the code, or like just a simple, like somewhat complex conditional that had a comment next to it. It's like, that should be a method. That should just be a method that says what it's doing, instead of you trying to describe what you're doing. And I think it's something I do a lot. And now, ever since having had that conversation with that person, it's something I see everywhere in the development that I do. And so I try and like call it out when I see it too, and, you know, see if it could be improved a lot. The other one that was sticking out to me, where was it? I think Jeff, you had tweeted about it, was the shotgun surgery.
Yes, absolutely.
But, you know, so I work in WordPress, and WordPress is shotgun surgery a lot of the times, like depending on what code base you come across, who worked on it, you know, low barrier to entry to get things up and running. A lot of high, like really great code in the WordPress community too. But, you know, more often than not, if you're working with a random code base, you're going to see a lot of like, you're going to have to make a lot of changes in a lot of different places to kind of get something fixed. And so I thought that was pretty funny.
That one's also a hard one. And the reason I said it was one of my favorites is because it's, so you come across it a lot and you're like, oh, I'm making this one change, and oh, now I've got to go change it in these 15 other places. And so it's like, but then at that point, you're you're betting on, okay, if I do all this refactoring, so I move this stuff around and I kind of combine the ideas into one place, then I push this into code review and everyone's going to be like, whoa, why did you make these gigantic structural changes? Like you were just changing this one little piece of behavior. Like that's kind of a tough balance, I think, to strike. Is yes, it's bad, but when you're in the middle of it, you're like, how much of this refactoring should I actually do right now? I mean, yeah, that's my take on it.
Right. And I think one challenge with that particular issue too is that it's a 3-paragraph section right there that kind of describes it, but really what it doesn't get into is like those different pieces that are getting touched when you make that change might not even be consistent between them. Like you might not have consistent variable names. You might not have, even though it's like kind of behavior that's related, the surgery you're doing is also for the purposes of cleaning it up is you're trying to like make it a little more unified, a little more consistent across those sections just to get to the point of being able to refactor it.
It's interesting because that kind of symptom is almost more of a culture problem than the programming problem is well understood, right? I mean, we can see it, we know how to deal with it, or we can open the right page of the book and understand how to deal with it if we have to. But the whole piece around how do you justify making the change is a really interesting problem. How do you build a culture where, after the first why did you do this, you explain it's like, oh yeah, good, okay, awesome. It should be gold star, not the job was just to fix one thing.
Yep, that's true.
Yeah, I don't know if it was my favorite, but I love the description of global data about there being a special region of hell reserved for developers who use global data. And it actually it chimed with me because I was working with a colleague on a JavaScript app that was prototyped, and obviously it's done very well, and now they're looking at restructuring and trying to make it more usable. And there was one file that had all the things in it, lots of global data and that sort of stuff. So I literally opened this page, I was like, okay, how do we deal with global data? Oh, encapsulate variable, great. And that's what we did for a couple of hours. And that kind of thing. The other one I liked was primitive obsession, which I think we see all the time. Just using strings for types. And I know
it's so easy.
Yeah, it may be less of a. Well, I don't know. At least Java has a support for enums, so and I guess like Ruby has with I can't think of the name of it, but the constants that don't have a value, the symbols, I guess that's what.
Yeah, symbols. Yep.
Yeah, but even then, I don't know. I see a lot of Java code that doesn't use enums, where it could do also those kinds of things. So yeah, those two are two of my favorites, I think.
So one that I encountered, and it seems is even kind of promoted, is all these data classes, right? For example, now in Java 16, they have this record, right? And it's the same as what Kotlin uses as data class. And it's a very common pattern. But I agree, it's bad pattern, right? We are just using this DOM structure, and then everywhere we are getting and setting, right? If we are lucky, we're just getting data from there. But instead of encapsulating the behavior in that class.
Yep.
So that's something that is very common. And for example, when we use Hibernate or some other GPA, seems that's the way to go in most cases, right? So, yeah, is even fighting that seems that is even against the trend or the expectations.
Yeah, I think I see what you're talking about. So like that, and part of this is interesting to me because like sometimes the idea of primitive or it depends on what language you're working, what kind of tools, depending on what you're doing, sometimes it makes sense to drop back into a more primitive, like to get the feel of how general like programs are working. And I think Jeremy, we were talking about this, Jeremy Ward, we were talking about this the other day, related to like adding objects in place of something that's like an array in like a PHP world. And so a lot of times when you're thinking about libraries or structures, like whatever you're building something for someone else to use, sometimes it makes sense to drop into something that's more native feeling in how they would use the code versus forcing a structure because it's quote unquote right. And I think that's where the Java enums or PHP is getting them, maybe we don't know, and then Ruby symbols and that sort of stuff, like using that tooling, and then JavaScript doing like constants in like a big class that you're importing individually, that all of that is native behavior of the language you're using. And so I think applying this idea, I would say, to me, it's like apply it cautiously. Like it's not always a bad thing. If you're doing something where you're literally passing around strings and those are all the things, yes, that's probably bad. But when you get down into the primitives, I think it depends. Like you have to look at it with a lens on what language you're using and what tooling you're using, whether it makes sense to do things in a certain way. And like an example of that that I deal with working in Laravel apps is so like the Eloquent, the ORM that they use. So like there's attributes. So all the database columns come back as attributes, and so you're accessing them as like model arrow, and then like a snake cased variable name, which is counter to like all the other programming standards. So it looks really weird. But then a thing that I find people reaching for a lot, and I do too, is you can add mutators and accessors that look like they're database columns. So now you're dealing with like you're treating it kind of like it's a primitive that exists on there and it came from the database, but it doesn't. And so like people use them for all kinds of weird stuff, like converting time zones for their date objects, or dealing with like changing a string based or like an integer to a float for money kind of things, like weird stuff that they're doing and juggling with types. So I think it's all that to say, like I think it is context dependent on, like, to me, like how I put this whole idea of what type should you use and when should you take something and extract it into a more complex structure. That was a long-winded answer.
Yeah, I think so Fowler starts this book, or this chapter, by saying to use this chapter in the table on the inside back cover as a way to give you inspiration when you're not sure what refactorings to do. So what's kind of interesting when you think about this, and we all have a copy of this, but you're recording this, you're distributing this online, other people are seeing this, they may not have necessarily have the context of like, what is chapter 3, what are code smells and all that. Like this is kind of like he goes over like this sort of like not comprehensive list of potential refactorings, but just sort of like probably the most common ones you're going to see. And so I'd be interested in hearing from the rest of you, is like, is there anything you think he missed? Like, is there something I wouldn't know about that isn't covered in this list? And it's I mean, we could talk about our favorites, but I'm also kind of interested in like, is there something that's not on here that he didn't cover somehow? Because when you're not sure what refactoring is to do, these aren't the only ones. Then this is just a place to get started.
Yeah. So this is my first time reading the book, and I haven't read anything beyond chapter 3. So, but it was kind of unclear to me how to read this, right? So I'm reading it online, so I can click and then go to that thing, to that way to refactor, extractor function, declaration, whatever, right? But it looked to me like it was not meant to do that. It was more like, okay, this is kind of general or generic ideas, or kind of some approaches that you can have, but I was not really going into each one of them or looking, okay, this, I don't think that is exhaustive, but yeah, I was curious about that too.
Right, Antonio, you're kind of talking about like the links to the different individual like steps that he takes. Right. Yeah. It's interesting because I like don't read the book that way either. I'm just sort of like, okay, I'm going to know this later. and I kind of read like, okay, this is what he's describing, and I keep hearing this or reading the same terms over and over again, and I know I'm going to know later on like what these individual steps are, and it's kind of interesting. I don't know if it's inside out sort of, because like you don't know how to do the thing that he's now talking about, but also you don't know what to look for and then how you're going to address it if he doesn't set this groundwork right now.
Yeah, what I think
yeah.
is interesting there is like that has a that's very meta in terms of what this chapter talked about. So it's talking about like naming of functions. If the function isn't named well to where you don't have to read the body of it to understand what it means, then you should rename it. So in that case, if you're looking at this from that with that particular focus, then if the refactorings aren't named in a way that you could just read this chapter and look at like a smell and figure out what they would be doing, maybe the refactorings need to be renamed. So like I think there are probably, I mean, there's definitely things that are missed, but I think what I take away from this chapter and like the structure of how this is set up in the book is like you're gonna find that there are a bunch of things that are kind of triggers for you to know this is how I should behave in this case. And I think these are good. This is a good kind of cross section of smells that, worked for what Fowler has done. And, some of them are universal. So like long function, like you open up a class or, something, open a file and it's 8,000 lines long. And it's like immediate, okay, there's going to be a lot of extracting of functions. There's going to be a lot of like, what classes can I pull out of this? So like I think that's what is trying to be set up here. And I don't think that like I would want this book to be exhaustive. I don't think that you could write an exhaustive list of here's every potential scenario that's common amongst programs, because there's probably billions. But I think the bigger thing to take away is look at when you're in code, when you're doing the steps like we talked about in chapter 1 and 2, in terms of like what do I do first. So like he talks about looking for temporary variables, and so like just as a general rule, you say when I encounter something, like I encounter a long function, or I encounter the fact that I'm changing this one thing, but I'm having to do searches in my code base to find 17 files. What is the typical thing that you do in that case? And that's usually moving stuff into modules or whatever it is. And I think that's what we should try to take away, instead of did Fowler cover every potential smell in a code base? Of course not. Like, I don't think anyone could. And as far as like things that are missing, that's tough, because like I classify things. I think that the list, from when I read it, the list is kind of exhaustive in terms of what I typically see, or like I associate them with things that I see in code that I write, and then code that I am reading a lot. So like I think he did a good job of covering the gamut of what like the general classes are. But yeah, I mean, there's probably going to be some like more specific stuff that would be, I don't think would have a place in a chapter like this, because you'd end up with needing to jump between, the back of the book a whole bunch to understand like very specific cases.
So I think that we can wait until we have code that has 0 smells before we can start trying to figure out which smells were not covered, because I cannot think of a single system that I work with at the moment that does not have one of these smells in it. So I have plenty of work to do before I start trying to figure out what's missing from the chapter. So,
and then when you get to, go ahead.
Go ahead, Jeff. You go ahead.
Well, I was going to say, when you get to 0 smells, then you just have to invent new smells. I think that's how it works, right? Like that in and of itself, code that is perfect and has no smells is a smell, I think, at that point, and you need to do some sort of refactoring there.
I was going to say, I wonder if this chapter actually does one other thing for me, and I think it's something that the second half of the book does, but I think it's an attempt to invent a vocabulary, a common set of terms of discussing this. And I think for me, the first time I read this book, this is the second time I read this book, the first time I read it, I was like, oh, this is where code smells comes from, right? The idea of code smells. And in a sense, maybe we can say it's been successful because it's a common term in our industry. We all talk about code smells. So therefore, assuming that this is the place where that idea was born, and it seems to be from reading it. But I think the real value of this chapter is you can say to someone, "Oh, this has a mysterious name," and instantly, if everyone knows what that is, it's like, "Oh, that's this, and therefore we should do one of these things to take care of it," right? It's that common vocabulary is true value, I think, for this, for me at least.
So it's like a common vocabulary, and then a building on a playbook. So like, you know, when you're talking about like, what do I do here? Mysterious name. Obviously, the first thing I do is this based on my experience. Yeah, that makes sense.
Maybe it's also, I mean, I've never studied medicine, but I wonder if there's something some of the doctors go through, that it's like, this is a such and such, and therefore the treatment is one of these things, right? And if the patient is presenting this symptom, here's the treatment. It's almost that little, but that in a much smaller way.
Well, I'd hope they know the names for those things, because I'd be scared to be in their care.
It's like, Bernard, you have a mysterious name, therefore your treatment is.
Yeah, that would be funny. Oh, you already knows. Let's see. Let's do an X-ray. You're like, wait, whoa, easy now. That's not the right refactoring step here. I'm sorry. I don't know. Yeah.
Another way that I kind of phrase this is, if we are writing new code, right? We can kind of, if we are aware of all of these code smells, then we can avoid them, right? We can stop them, right? It was last week talking about, so we are doing our major implementation system. So we create an interface, and basically the whole implementation, and then implementation now kind of satisfy this interface, but the whole implementation doesn't really need most of the data that the new implementation needs, right? So they was saying, oh, this is a problem of a refuse request, right?
Mm-hmm.
So now how can we do this better? Because at the end, passing the data or retrieving the data takes time. And if it's not going to be used, then it's kind of we're wasting there. So what I'm trying to say is that it's not just kind of fixing somebody else's old code. It's also about things that we are doing or just this.
That's sure. I think. Oh, sorry. I think he does kind of lay Fowler kind of says early on too. Like I think like this gives you the vocabulary and the I don't know, the knowledge of what you need to do to be able to approach it like the right way the first time. But I think he also did kind of cover in the earlier chapters how through like deadlines and other sorts of things, you know, you start off with what you think is like a really great code base, but then over time it sort of erodes. And then so even though you have the best intent and you might start with that, I'm going to think of that as pre-factoring. You did it great. You did it perfect the first time. I think you're right, Antonio, that like, you know that up front, but then of course, as time goes on, the code base erodes and you still have to come back and look for these sorts of things and find out if something had happened that suddenly like some code's not relevant anymore, or like, you know, you've got just completely dead code and you kind of have to like tie things up again. So it's still like an ongoing process, even if you started with like that perfect code base. Yeah.
And I think like to the same point, like I think it's, you know, part of what this is like the system in general that's being built here is, you know, it's not just about like someone else's code base or new code base or whatever that you're working with. It's, you know, like integrate this into your process, like your personal process of how you do things. Like for me, it's typically, you know, I get something, I want to write some code. So I write whatever, you know, gets the job done. So like, I'm not thinking about, am I violating the method chain here or, you know, whatever. Like, I don't think about that up front. I think about it before I push that into a PR, but I don't. So like, I like the idea of setting up a playbook that you're applying to your own stuff. And that's kind of why I started off with, you know, what's your favorite ones? And then which ones do you write the most of? Because like, I think if we start recognizing this A, as we're writing, but then B, as we're thinking about integrating it into the project in general, it's easier to start applying these things in smaller chunks versus memorizing an entire catalog of names and like applying them. I think, to me, it's nice to have the names for sure, like especially when you're having discussions. But what's more important is that you recognize the patterns that you're seeing, and then how you mitigate those first in the stuff that you write, either as you're writing it or as a follow-up. And I think over time of doing that, you'll eventually get to the point where you are prefactoring, because you recognize, I typically write this. Like I always reach for loops, and we won't even get into the fact that loops are a smell in this chapter, because that's a whole like tribal thing, I think. But so like I always just go for loops, and then that your typical refactoring is pipelines. So like that's how you generally work, based on your initial understanding is this iterative approach, and then you actually move to a more pipelined approach, or whatever, however you want to look at it. So maybe over time your process changes from first reaching for those for loops and then immediately reaching for the pipelining tools, because you're so familiar with them from having done that repetitiously through your own code that you're writing, right?
Kind of along the same vein, and I was just thinking about this based on what Antonio just said about writing new code and being able to avoid these kind of smells. And a couple of years ago, I watched a presentation by Sandy Metz, and she was talking about refactoring in terms of the Gilded Rose Carter. And in that presentation, she was talking about how, as developers, we frequently think, I'm going to do something that's going to be duplication in a second, therefore I'm going to put this grand abstraction in place. And what often ends up happening is you end up shoehorning your code to try and fit the abstraction you had in mind. So she said her quote was literally, I don't think I'm paraphrasing, but she said, it's much easier to refactor later to remove duplication than it is to refactor later to remove the wrong abstraction. So, and then that struck me with this is like, in terms of like code smells, is there something there that you accept, that you just write the code? You accept that you've got duplication or whatever other smell. Maybe you've got a bad name. Maybe you've got long parameter lists. I'm just looking at the book over here, of course. But and then you write the code, and then at some point you go, you know what? I now understand a little bit better what's happening. I can now think of better names. I can now think of better structures. I can now, actually add the correct abstraction to remove the duplication. I wonder if is that something that all of you feel as well, or is that something I'm just making up?
No, 100% agree. So like, I think the biggest disservice that we in general have done is like hammer dry to people, like just, don't repeat yourself. Like people are just searching for, oh, I wrote the same line in 15 or in 3 places, so I've got to automatically abstract it into something else. Like now, instead of looping over something, I need to have a looper class. Like just like we've hammered that whole concept of don't repeat yourself really hard, and I think that has led to that whole premature abstraction, where now you're guessing, you're speculating. So you're doing that speculative thing, and you're guessing about what could be and what should be based on all the inputs that you've had from previous years, or what, like your previous experience, and then you're basing your assumptions on like this limited view. And yes, it's absolutely the case that it is much easier to pull an abstraction out of something than it is to break an abstraction down and then build the right abstraction. So yeah, I mean, there's a ton there, and like, yeah.
More so
It
too.
also-
Oh, sorry.
Go ahead, Tom.
I was just going to say that it also, like, I haven't watched that presentation, Jeremy, maybe I should, but it felt to me that from the smells that were there, Martin is definitely giving us the courage to not be afraid either way. Like he has some refactorings that are about getting something specific and abstracting it, and also going from abstractions to something specific. So it, to me, it feels like it is all about making sure that from the very beginning, you have a framework that causes your code to be able to evolve. And as long as you have that, then it doesn't matter. Like it doesn't have to be clean from the beginning. You don't have to pre-factor. You don't have to just like do what works. And the other part that I think was very interesting is that this started it kind of like connected back to what I think is the heart of this book, which is this this theory about change. Like it's all about change, about being able to change code easier, making it more maintainable. And I felt like some of these code smells really pointed to that, because you could only identify them if you will take a second and say, okay, instead of going and changing everything as soon as I find the problem, I need to stop for a second and analyze, okay, who all is using this function, for example. Like as I change it, I need to identify how does this affect the rest of the system? Or some of them were like, oh, if all of these things work together, I'm like, how will I even know that these things work together? Other than like in runtime or with like some very sophisticated tool. Maybe they already exist. I don't use them, but maybe there are some tools out there that will tell me like, okay, these are all of the intercorrect connections of code in your system, and here's an opportunity for you to bring all of those together. So it felt more like kind of like this new DevOpsy kind of ideas of observability and monitoring, and like really understanding your code in a way that is not just mechanical. I go there, I start changing things, and all of a sudden everything is better. But like it takes like a bigger context, which is outside of the code itself. Like how do things change? How is the organization using the code? What changes more often than other things? To me, that's what I found really interesting about this chapter, is that I started bringing in some of those things inadvertently in some ways.
There's
Yeah,
also
sorry, you were touching on kind of a similar thing, which I was going to mention before, which is that he does talk about kind of the distinction between like private APIs and public APIs too. So if you've got code that's being extended in some way, you have to be wary of the callers when you're doing the refactoring and making sure you get them all. And you might work in an environment like I do, where you don't know what all those callers are, because you might have public libraries or something like that other people are extending. And so you have to be very cognizant of it as well, and doing a proper deprecation and everything. And I like that he got into that a little bit in this chapter too.
I guess coming back to the idea of not cleaning up code smells too soon when you're writing new code, I guess it's maybe the smell to watch out for here is leaving it too long, right? If you're working for 4 days and then you're like, now I'm going to go back and clean up 4 days worth of stuff, that's probably a smell in itself, right? There's got to be a sweet spot there between fixing everything as soon as you do it and waiting too long to take care of it, I guess.
that's a process smell. It's not a code smell, right?
Sure.
So does anyone else think that long parameter list is a refactoring left undone?
Sure, Jeremy.
In many of his examples, he's like, I'm gonna, do extract method, and then we're gonna bring in all these member variables, and then we're gonna slowly whittle them down. It's like, oh, man, I started doing that, and now I got pulled into this other thing, and we just had to wrap it up, and now we got this method with a long name, with a lot of parameters.
It
Kind
could
of a half
be
joke there, but
yeah, no, it could be. Like I see your point. Like it's it'd be like in process, right? It's like when you're in the middle of refactoring, you end up, you've inlined a bunch of stuff, and now you've got this. Yeah, I could see that.
I have to see that like as a step towards honesty, though, because I've refactored some code recently that newed up a bunch of variables in its own. It used a service locator to pull in other things, and the refactorings instead used constructor injection, and I ended up with the constructors that had 10 or 15 parameters. But and you know what? I actually committed that code. I didn't go any further at that point because I said, this is better. But it's kind of a honest intermediate step. It's like instead of hiding the fact that you've got so many dependencies, you have to go read the code to see them. Anyone now looking at this code can just go, oh, look, there's 15 dependencies this class has. That's probably not good. Or they should go, that's probably not good.
It's the clarity aspect. And that's also like earlier when I was talking about the tools that you game to get to a good score. It's like you're hiding the fact that you have a bunch of problems, but you can always in code, you can always hide complexity in direction, or you can hide them in, let's just group things. And like, instead of 15 constructor arguments, we only have 3. Don't pay attention to the fact that all 3 of those are actually like these dumb data objects that I created that house, 8 things themselves. So don't pay attention to that. But look, only 3 parameters. It's good, right? Like, yeah, I think it's, and that, like, I do agree. I think I would rather have the constructor argument or the constructor with 15 arguments. So it's very glaring. Hey, there's probably a few things going on in here. We can rework to make it easier to understand how to even use this thing. And then the other side of that is like, I know I find myself doing this a lot in tests, where it's like, oh, it's really complicated to set something up. And because of that, I'm going to like make some sort of test helper. And then that test helper is going to call this other thing that creates the object that I need. And then now this is going to pull in these 5 interfaces and put them here so that now my tests all work. And all I do is say, pass this one little argument. And it's like, yes, you're lying though, because the people who actually use this have to build all those up or write the same weird abstraction. So why not just fix the problem?
I like that.
One point about, go ahead.
I was going to say, like, I like that. And since the next chapter is tests, I do wish that he had kind of done an outro in this chapter. It felt like it just stopped.
Yeah.
And now we're just going to jump into tests next. And it would have been great to kind of talk about, like, maybe, how some of these code smells could have been, addressing these kind of like leads into making it easier to write tests, or, how, I know we're going to get there, but it felt like a very sudden ending.
Yeah.
Great.
Going back to the leaving smells for too long, I don't know that matters if you truly believe the whole change thing, in the sense that smelly code that never changes, it doesn't really matter, right? Like if you're never going to have to touch it again, then let it smell in its corner, right? But smelly code right in the middle of the room, that one definitely matters. So yeah, it all feels more like a process versus like some rule about something.
Maybe it's also how much time you've got to clean up the smells. Like in the case I just gave a couple of minutes ago, like I had, it's less smelly than it was before, but it still stinks. But the next person that comes along will hopefully, go a step further forwards, and it will gradually get cleaned up over time.
It's a different stench, right? Maybe you sprayed some Febreze or something. So now
yeah, there you go.
A mixture of yeah.
Yep.
I'm gonna use that logic, Gerardo, on my laundry. I'm just gonna put it, let it stink in its closet. All right, it's fine. Don't worry about it. If I don't need that shirt, if I don't need that shirt, just let it sit. It's fine. No big deal.
Let us know how that goes. I'll be curious to hear.
I will. I'll be from a different location next week.
Yeah, there you go.
He didn't talk about this much in the chapter, but I'm wondering if he's focusing on you, assuming you're the author of code, you're seeing these code smells yourself, or you're looking at other people's codes. I think for you as the author, you might even need time to kind of step away and read your code again. You need the time to read it and to recognize some of these things, because they're not always obvious. You're sometimes in a mindset, in a flow, you're thinking about things you may not recognize. Oh no, I have a temporary variable, or one of these things. I think it's a lot easier to spot in other people's code because you're not attached to it. You're not necessarily involved in how it was created, and you can spot those things much easier. So I'm curious, what did you guys think? Like, which perspective is he looking at? Is it both as you, the author, or are you reading someone else's code, or maybe just the author? Because I feel like that wasn't really addressed.
Yeah, I kind of thought it was more like the perspective was looking at someone else's code. It was like, because I guess he even sets it up as being, here are some signs of things, like what do you refactor? So right from the beginning, it's the sense that the code is already there, therefore you're looking for something, for reasons to why it might need refactoring. Yeah, that was an interesting one, because there is that very different perspective, right?
I do think it's like, this is all predicated on the fact that the code exists before you're even thinking about this stuff. For me, I think it is geared at someone else's code, but one thing that I try to do and this is really hard, but like one thing I try to do is you write code, put it into a pull request, let it sit for a little while, and then go review it myself. Just kind of go do something else, and then come back and open that PR and kind of look at it, and then even preemptively comment on things that are like, hey, this is, what I did. I did this because these reasons or whatever, and then use that as the first like conversation. So like you're now reviewing someone else's code, meaning yourself from 10 minutes ago or an hour ago or yesterday or whatever. And a lot of times that leads to like me saying, oh, that was really stupid. Like I shouldn't have done that. Like it doesn't make any sense. Or the whole, oh, I've got these weird temp variables, or I didn't even think about the fact that I, duplicated this method essentially because I named it this, and then there was actually one that already existed that's 10 lines below it, and now I'm just seeing that. So yeah, I think it is assuming that you're looking at someone else's code, but I think that person could be you. Like that's really challenging to do. Like I'm not saying that's easy, and I'm not even saying I'm good at it. I'm just saying I try.
Sort of that idea of if you look at code you wrote 6 months ago and you don't think it's bad, you're not growing, right? It's sort of if you look at code that you wrote 6 months ago trying to meet a deadline and you don't discover something that was kind of off about it, or see any code smells, you'll be more likely to see them because you most likely have grown in the last 6 months and you've kind of had more experiences and seen other approaches to solving problems.
The interesting thing there is, so like when you're writing something against a deadline or against like a, I've got to just get this done kind of situation. Do you find that you write comments there like as almost excuses, or do you just like roll with it and say, oh, whatever, someone will assume, or I'll know. Like I don't know, like I go back and forth sometimes about whether I want to put in a the infamous to do fix me thing, like because you never actually do those, but should you like blatantly, I know that this is a smell, I know that this is bad, not an excuse, but say, here's what I would have done, or here's what I thought I should do, like as just a way to know in the future, to give yourself a prod? Or is that a terrible idea?
Another form of speculative generality.
There you go.
I don't know. I mean, I kind of see the merit of doing it. But the other part of me thinks that when you see this comment in 6 months' time, the way you thought of doing it 6 months ago is probably going to be superseded by some other thing. I don't know. It's a tricky one. I mean, the other reason is those kind of comments in the code. Is there an element of covering yourself? You're almost like, you know what? I know this sucks. It's not my usual work. Go and look at this other thing over here. That's my usual standard of work, or something like this.
Oh yeah, that's a good idea. You should always suffix all of those with, my favorite lines of code that I wrote are on in this file on these lines. Go look at that, and then come back and do whatever you're going to do with this file. I like it.
Yep.
I do think there's an element of like you're racing for that deadline, and you maybe like set up some sort of architecture that is just not quite right, and it's causing some weird knot in one section of the code, and it's just like it's working, you've got it working, you've got like tests in place, and you're there to ship, and you're just like, you know what, if I change this right now, it's going to unravel everything. And I think if you don't leave any sort of context behind why it's like that, you might not ever realize it. You'll spend a bunch of time like kind of like digging into what's wrong with it down the road, versus if you just say like, hey, this is like a little funky. We try, you maybe don't need to get into like we did XYZ, but maybe you dig into it in the PR, and maybe you leave a reference to that PR or something like that, or the issue. I don't know what the right answer is. But I do think it's nice sometimes to just have a little bit of a breadcrumb so that you have some like head start on that train of thought 6 months down the line when you do ultimately come back to it for some reason.
I'm mainly just curious about, people's feelings on it, because I've run across those comments, in every project I've worked on that's, more than 5 years old. And I always go, get blame them or whatever, and figure out, when was it written? And then is what they said in here even correct anymore? Like, is this where it should be? Or like, so like I tried never to write those comments unless it's like a immediate follow. Like I know that so an example, like, recently we're working on something and fundamentally changed this one tool that we use. And then there's this one piece that made an assumption that was no longer true in how the tool worked. And so in order to get the bulk of the thing merged so that other people could work off of it for something they need to do, I commented out this, 10 or 15 lines and said, to do, this is broken, this assumption is wrong, it no longer works in the tool version, whatever, and then push that, and then immediately filed a ticket and opened or started a branch with a, draft PR or whatever that says, I'm fixing it here, as a way to like keep myself honest so I don't become the person that I'm looking at in, 5 years. It's like, you said you were going to fix this. What happened? Like, it's not fixed. But yeah, I mean, I tried to never do those just because I don't think I don't think that it actually helps anyone. I've, the code bases that I've been in that have like the novel written, comments that are like, here's my thinking. And, I went to school and I had Starbucks this morning. And then like, it's like this huge story in comments that are explaining all the things. And it's just like, instead of that, just take those 5 lines that you had, those 25 lines of comments, and put it in a function that says this, like, is named that. And then that's way better on everybody. So I've never been to a point where it's been like comments have provided that value to me or even shown me the way. Like, it seems like more often than not, they're red herrings, right? Like you end up, oh yeah, maybe I'll do that refactoring that Jeremy suggested. And then it's like, wait, this is a bad idea. Like I shouldn't have done this. I'll leave it to y'all which Jeremy I'm talking about.
Yeah, say never do the ones I suggest. It's never a good idea.
But I do like the idea of having a function named this. I went to Starbucks.
Yeah.
Yes.
Starbucks fueled bad idea or something like that, right? That could be a thing.
It's the first stage of naming is a process. Have you all come across that article?
Mm-mm.
I don't think so.
Like Bernard at least will be nodding his head because I go on about this a lot. But there's a great article by Arlo Dalshi that talks about naming as a process. And he says that, and the basic thing is you never get the name right to start with. So coming up with a good name for something is a process. And he outlines 4 stages. And the first one is just nonsense. Just if you can't think of a name for it, just like Martin Fowler does, applesauce, tacos, nachos, whatever you want to call it, right? Second one is honest. Name it after exactly what it does. And that kind of, the honest name is, I went to Starbucks this morning and thought of this while I was drinking coffee, or something like that, right? It's, but then he talks about how you break it down through the 2 other stages and you finally get to the, decent name that's domain specific and actually, succinctly says what the thing does. It's an interesting article. I highly recommend it. Actually, it's worth looking up.
Down. Thank you.
There was one other smell I wanted to talk about, and that was feature envy. And he says that you see so much code where the code spends more time talking to other functions and methods, getting data and performing calculation, and that's such an obvious smell. And I wonder. I see it so often. I wonder if it speaks to something about how human brains work versus how we have to think about object-oriented code. Because naturally, when you're in code, you're going through and it's like, okay, here's the place where I need to make the change. It's an existing method, and you just go, I'm just going to put 5 more lines in here. And then the next time you're like, it's just another 10 lines, right? But the natural human thinking seems to be, here's the existing place where something similar happens. I'll just tack it on here. Whereas in object-oriented code, that's usually not the right way of doing it. It's only like, we normally need to think of another method or another class or another abstraction or whatever it is to hold this thing. So I've often wondered if there's something here that the way that humans think and the way that we structure software are kind of not quite unified, if that makes sense.
I think it's just hard to keep architectural consistency in your brain. And so when you're going into something that already exists and you already forgot a big part of the context and you just have one new idea, an object just feels like the right thing to encapsulate that idea in, even if it doesn't belong in an object. But then, hopefully if you continue to follow this ideology, eventually you will find out that, oh, these are like one-to-one mapping and nobody else cares about this, but this one class, and then you figure out that you should merge them. But so yeah, my intuition is that it's probably just lack of context, and you just want to isolate this one thing just in case that isolation is needed to begin with.
I think I think the general advice I think that he gave in the chapter about like how to spot feature envy is it's typically something is accessing a bunch of small pieces of data out of somewhere else and then doing something with that data. So it's like to really get around it, like is it like what you were talking about, I think, Jeremy, is that someone has done a small chunk of that. So they like pulled one piece of data out of this class or whatever. They use the access, or they got one piece of data and then they did something with it. And now you're adding something else that uses another piece of data. So like the natural tendency is I'm already accessing that particular, dependency here and doing something with it. So I might as well just continue to do it here. And like, I think that's the rule should, in your mind should generally be, whoever owns the data gets to interact with it. And like, I think that's one of the things that I've grown out of is, you're building like a class. And so you immediately start with, let's add public getters and setters for everything. And then like everything could just do like interact with the data if they want, or they can call like, like the typical examples are like, calculators or that sort of stuff where you're doing like shipping calculation. And so you're like, I can give you all this information and then you can multiply it and figure it out. And like, so you have to think of who owns or who should own the data, like which module, which piece of code should own the base level information that you need to do the manipulation. And then that's where it should be. And I think it is what you were saying. I think it is kind of counterintuitive to make that change. Like you see it's already there being interacted with in someplace else. So it's just natural to say, I'm just adding one more small calculation, or I'm just pulling one more piece of data, so I don't need to move it, but you actually do. Yeah, I think it is an interesting one.
Yeah. I wonder if it's even, I've been thinking about it or listening to what you're saying, that as humans, we tend to be like, I'm going to go and look up this thing, and I'm going to find this thing, and I'm going to get this thing, and now I'm going to calculate this other thing that I need, or I'm going to create this thing that I need. It's very rare that we go, I'm going to go and create this thing over here that then is going to give me the thing that I need. Right? I'm not sure if I'm losing my ability to describe the problem is less than how I see the problem itself, if you know what I mean. But it's yeah.
Well, if you think about it, we've applied this to our lives like almost everywhere. Like you're like, oh, I need to buy something, so I need to go talk to this bank. I need to pull this. I need to transfer this money here. Like everything is kind of built in like, even we structure like companies that way, where it's like, in order to get a product done, there's immense numbers of groups that all interact, but it's like, who actually owns a product being built? Like, is it the people who are building it? Is it the sales team who's selling it? Is it the CEO who's pitching it or whatever? Like, how do you figure that out? Like, I do think it is kind of natural. And it's, like I said, like counterintuitive to actually see that stuff clearly the first time. And I think that's probably one of those smells that it just takes time to actually root out. And so like, it's one of those that I think would lend itself very easily to like building up abstractions that don't make sense. If you're like on the hunt to fix this particular problem before it actually exists or is a real problem, I think that's where you'd end up.
What's really dangerous is that so like you say, we create these sort of bad abstractions, but then because people don't know any better, they become the abstractions, they become the domain that you're working with. And so you just continue to build more and more structures around these bad abstractions. And so yeah, it is kind of hard to step back and once again, like talking about some of these mails that like really require for you to analyze kind of like the paths through your code to understand how things interact with one another. Like stepping back and looking at that and seeing like, oh, this abstraction was bad. A new abstraction is needed. The code is telling me this. The way the code is being used is telling me this. But I mean, I gotta confess, I don't remember the last time that I took that time to see like, okay, what are the actual true domain objects that should exist versus what's currently there.
I think maybe one other angle of it too is like there might be a case where in a feature envy situation that the object that you're calling and the object that you're calling it from, neither one of them owns the data that is needing to be done.
Yep.
And it's an extra step to kind of identify that even. Because there might be some sort of intermediary that needs to deal with it that then serves it to the other object that gets you back what you need. And depending on your level of skill and your ability to kind of recognize that, it just might just persist. And so I think what you've all said about like the human brain and going shopping or working a business, I think that all makes sense as to that seems the easy way to getting the thing to work.
Yeah.
And then, can you refactor it from there and learn to identify that and figure out how to separate it?
It's interesting because I mean, what I was saying that one of the classic examples where domain-driven design talks about the idea of domain services, that sometimes an operation is not owned by one entity or another. And I think one of the classic examples is transferring money between two bank accounts.
Mm-hmm.
That if you had an object representing those bank accounts, neither object owns the transfer. So you put a domain service there. I wonder if some tools would even then would warn that as an instance of feature envy, because what you end up with is the domain service spends more time calling methods of other objects than of its own, which strictly speaking is feature envy. Obviously, in that case, again, it maybe points to all of these things are just warnings. At the end of the day, the human has to decide: is this really a smell given the context that I'm working in right now?
Right, and if it's easy to understand and easy for other people to follow like what's going on, like that's ultimately what wins out, right?
Exactly.
We're back to the academic versus the practical, like what's the reason we do all these refactorings, what's the reason we look for these smells? It's because someone needs to understand what's happening. So when you're talking about the the domain service or the thing in the middle operating, I just imagined that guy from Office Space. It's like, I'm a people person. I take the requirements and I take it to give to the, like, I feel like that's like, we're talking about that person in code is the one who's like, no, I go to the bank account and I go to the other bank account and then I take the money and I switcheroo it. Like that's kind of, that is, we need to come up with a name for that.
Yep.
That should be,
maybe
it's a shell game, right?
Yeah. It's really interesting. Later in the book, in the catalog, he has refactorings that do the opposite of each other, straight after each other. He has introduce middleman and remove middleman, two refactorings, and they're right after each other. And I think it's the same with inline method and extract method and stuff like that. But yeah, it speaks to that there is no right or wrong answer, I guess, right? It's all context.
So what you're saying, Jeremy, is the best way to increase your commit counts in projects is you do one refactoring, push that, then you do the other one, or you do a cycle of them, and then you end up with like, look, I've changed 8,000.
Yeah.
Like, yes, but you didn't do anything. It just does the same stuff. I don't understand.
You want one of those little statues that GitHub was sending out at the beginning of the year, don't you? It's like your commit history modeled.
Oh yeah, the skyline. Yeah, the skyline. Yeah.
That's how you get one.
I said like if you were looking for a justification of anything, you should just get that file and print it out, like 3D print it, and then send it to whoever's asking you like, what was your impact? Be like, here you go, here it is, physical form. You're welcome. Yeah.
The longest time. I worked for an agency a couple of years ago, and for the longest time, my impact on one project was negative lines of code. I think by the time before I left, I think I just tipped into the positive, like a couple hundred lines or something. But I was like, like 1,000 lines more removed than I'd added, or something like that.
Nice. That's always the goal, right? My goal is always the PR that has 0 greens and like
Yep.
8,000 reds. You're like, yes, look at what I've done. I've made things better for somebody or something like that.
Productive day.
The other one is to rib people in the opposite direction when they like make changes in node modules or something, and so like the lock files are committed, and it's like you were making one small change and yet you committed 22,000 lines added. What are you doing? Like, get this out of here. That's
Nice. Yep.
my favorite. Cool. Any closing thoughts? I think we're running over time now. No closing thoughts.
No closing thoughts.
All right.
One thought, I guess I can close with a thought.
Yes.
I thought this chapter was very interesting because when it started, I got these really bad feelings in my gut about them talking about something kind of prescriptive, like we're gonna tell you when you can refactor, and I was like, that doesn't sound right. And then they're like, oh, these are just opportunities to refactor, and I'm like, okay, that sounds a little bit better. And as it went along, then it just got really abstract and very cool about how I was starting to think about the system. So yeah, I love this chapter. I thought it was really great, and it really made me start thinking about some of the systems I'm working right now and how I should be analyzing them for them to be better, have better architectures. So good one.
Awesome. Yeah, I can't say any better than that. So thank you all for the discussion tonight. I think it was good. I'll see you next week for chapter 4 and 5. Chapter 5, make sure you read that one early. It's like 2 lines of reading. So just so you're aware. All right. Thanks, everyone.
Thank you. See y'all.
Thank you.